Okay, let's continue. Didn't give you much of a break, but that's life. Alright, everyone's been asking, how do I set up my Postgres server? So let's have a look. Alright, where am I at the moment? Ooh, where am I? There I am. I'm in /server/jazz. That directory got created because I logged into Greek and ran the command print server. I can run it again, it doesn't recreate /server/jazz. So you only need to run that once to get that directory. Once you've got that directory, well, mine's got stuff in it that yours won't have, but one thing it doesn't have an end script, nor does it have a PGSQL directory. Okay? To make that happen, there's a one-time, this one's interesting. On Greek, a one-time only running this script here. So that does a whole lot of stuff, including making a copy of the end script and also setting up a PGSQL directory. And it does that for a while. Okay, so now if I go back and look at this, you can see I've got two things I didn't have before. I've got an end script and I've got PGSQL. Okay? On Greek, you only need to do that pginit once, and that will set things up for the rest of the term. What you need to do on Greek, each time you log in, you need to source the end directory, the end script, which will set up all the environment for you. Hopefully I've done that right. And then you can go pg start, and that will run your server. And you can tell your server's running by just doing psql-l, and you'll see something like that. And of course, by doing that, by deleting the original PSQL directory, I wiped out the database I was just playing with. But hey, that's life. So it's pretty straightforward. If you want to run, Postgres on a different server, you can, but each time and you can't run it on all the servers. Some servers are dedicated to running other stuff, not for running Postgres. So if you log into a machine in the lab, they're fine. If you log into the systems people told me running a directory on VLab was fine. I'm a bit skeptical about that. But in any case, if you're running it anywhere else apart from Greek, you'll have to run pginit every time you want to have a session with Postgres. And what that's going to do is going to completely recreate your Postgres server. Okay? Which is alright, as long as you've got dumps of the databases that you've been working on, you can always restore them. If you wipe out your server and you didn't have copies of the databases, then you've lost them. What else did I want to say? Oh yeah, in theory, you could run a Postgres server on another machine and use the stuff that's set up on Greek. That'll work, but I think you'll find that it's quite slow. So running it locally on a workstation is going to work quite fast. Running it on Greek using the Greek Postgres configuration is going to work reasonably fast until there are 300 of you all logged in at once trying to finish the assignment. But running the server on some other machine, accessing Greek isn't necessarily going to be super efficient. So I'll have to rebuild my beer database. And one reason why I've been holding off, let's see, COMP3311, week 3. Well, remember that all of these exercise solutions will eventually end up attached to the website. Alright, so here's how I build this. I didn't do a PG dump for this. These just scripts. So I created some domains, assuming that every name was going to be less than 30 or 20 characters long. Create the tables, all the tables, and then that's got no data, but let's see, what did I just do? I made the database beers. Okay, so that's just loaded up schema. So all the tables are there, but they're all empty. I need to populate them, and there's a separate file for doing that, file called data.sql. So having done that, I've restored the beer database the same one as I was running before. Now, one important thing to notice here is this version, and this is the reason I've been holding off on releasing exercise 2, because Greek hasn't yet been upgraded to run Postgres version 11, which is what's running on all of the other workstations in CSE. Hopefully tonight they might do it, in which case then you can get started. But one thing, if you create a database in Greek, at the moment it's going to be Postgres version 9. It's not, the database that you create there isn't really going to be useful from anywhere else. If you use PGInit on a different workstation, it's actually going to create a Postgres version 11 database. But those databases you create elsewhere are going to be temporary, so it doesn't matter. The databases you create here can last for the entire term. If you absolutely screw everything up, then you can do something like this. Well, should stay in the directory I was in. Ooh, that may have been a mistake. Oh dear. I think I had a server running, didn't I? And I've removed all of the configuration files for that server, so it's just floating loose in process land. I think I'm going to have to find it and kill it. Yeah, that one. Oh, I'm not going to be that harsh. That might do the job. Yeah, right. Happy. So that's gone, that Postgres server. I mean, it would have sat around just running and being a nuisance, so it's definitely worth getting rid of. So, because I've removed my environment script and I've removed my PGSQL directory, I need to recreate it. You wouldn't do this every time you log into Greek, but I was just demonstrating for a second time. Run the PGInit script. It happened to work just by typing PGInit that time, because I already had my environment set up. So now that I've run that script, I've now got environment script has come back, and I've got the PGSQL directory set up. So now I can restart the server. Yeah, good. Gives an error message. Nice. If you can't be bothered typing start all the time, just type 1. PD1 means go on, and 0 means off, so that'll stop the server. Alright, so So now, oh dear, my beers database has gone away because it lived under that PGSQL directory that I removed. So now I'd have to go back and recreate it. What did I call it? Beers before. Doesn't matter. Alright, so I'm back online, ready to play with that some more. So that's the kind of thing, in fact, if you're logging into a server other than Greek, that's what you're going to have to do every time. Do pginit, it'll give you a completely empty Postgres system, no databases apart from the ones that it provides by default, and then you'll have to rebuild the databases that you're playing with. Most of the time you'll have dump files that you can use to load stuff up. Right, so now we're back here. Alright, so we've got all this stuff back here. Let's keep looking at the queries. How many beers does each brewer make? I reckon hopefully by now you should all be able to do that one. It should ask you to chant. Select, comma, from. It's not going to work, is it? Alright, so we're interested in how many, i.e. a count, a number, associated with a manufacturer. And because they're really a brewer, I'll call them that. So we need a count, we can even call it beer if we like. No, we can't, because there's no such thing. But we can call it name, because that's the name of the thing. From the beers table, alright, so if I just did that, in fact if I just did that, I'd get an error. So what I want to count is I want to count the number of beers associated with a particular manufacturer. So the first thing I have to do is group all the tuples by manufacturer. And then count will count the number of tuples in each of those groups. So let's hopefully that will work. Okay. So we can see the number of beers that each manufacturer makes. What was it complaining about? It's that. Was that error coming from earlier on? Yes. So, alright. So it turns out that we're actually going to need to use this later on, so I may as well turn it into a view. Let's call it N beers, and let's say that it consists of brewer and a count of the number of beers as actually, to make it even simpler, I'll call it NB. Alright, so this will create an object called NB, which I can invoke just like a table, so I'd stick it in the from clause, and it will run that query and give me the result. The fact that I've put these names here, they're going to be the column headings in the final result. So it's kind of like the attributes of this virtual table called NB. So it's created that view, and now I can go select star from NB, and I'll get that result. Okay, so it tells me for each brewer, total number of beers, runs that query each time. Alright, I'm sure there are some queries coming up that require that. If you want to look at a table in Postgres, you can do something like that. If you want to look at a view in B, you can do that. It doesn't tell you much. If you want to get more information, you have to put a plus, and that applies to a lot of these catalog operations in Postgres. You put plus, you get extra stuff. So well, it doesn't give you that much more. Right, so that tells me something about what NB looks like from the outside, and maybe if I put a plus here, it will also give me the view definition. Right, so \d plus is what I was after. \dv generally just gives you a list of all the views in the database. So I've got this view called NB. It has two columns, brewer and NBs. The first one is effectively a varchar 20. The second one is an integer. And you can ignore all the other stuff, but that's potentially interesting as well. Right. Next query. Which brewers make only one beer? Aha! So this view is going to come in extremely handy for answering that query. So I can say I want the brewer from NB, where the number of beers is equal to 1. So that'll give me those ones, right? So having that view makes it quite easy to answer that query there. If I didn't have it, well, I'd have to write a bigger select query. Which brewers make only one beer? I've already answered that. Find beers, and this is kind of a little bit the converse of that. Find beers that are the only one made by their brewer. This one introduces some new idea. Maybe it doesn't need to. Let's see. So if we select a beer name, so we're interested in all the beers, and we want to join with this magic NB view. So even though NB is actually a query on beers, we can still use it in other queries that involve the beers table. So let's see, that one's probably not going to tell me anything super interesting, because all I did was print the name. What I'm probably interested in is so this will give me a beer name and the number of beers that are produced by that particular brewer. And I'm interested in the ones that are the singular beers from that brewer. In other words, the brewer makes only one beer. So in fact, we don't care about that because we know that it's so we can do it that way. So we're filtering out just the rows that are related to manufacturers who have a single beer, and that will give us those ones, which we can cross-check. Always a useful thing to do. 80 shillings comes from a manufacturer that has only one beer. ogre, well, chestnut lager, and so on. Now that assumes that the NB view is correct, and we should have checked that when we created the view in the first place. And a way to do that, simply select from the whole beers table, maybe order by manufacturer, and then look at the ones where there's only a single beer. So this is really just error checking, if you like. So there's 2 Brewdog beers. Bridge Road Brewers Chestnut Lager, there's only 1 beer by that brewer, 80 shillings, there's only 1 beer by that brewer. Lots of beers by Carlton, 1 beer by Cascade. What else? George the 14th. So if we looked at NB, we only ought to see those brewers that we count in there as having 1 beer. So let's just double check. Really should have done that earlier. So Bridge Road Brewers, we saw Cascade, Caledonia, and we could keep cross-checking to make sure that NB was working. So NB is working, so all of the queries that we built that involve NB presumably are also correct. Now there's another way that we could have done that. That we could have answered the query, tell us all the beers that are the only one by their brewer. So let's just right, so they're the brewers we're interested in, and if I just took the brewer from there, that gives me a set of brewers that make only 1 beer. So that previous query, give me all the beers that are made by a brewer that only makes 1 beer. You can just kind of rephrase that as, give me all the beers that are made by a brewer that belongs to the set of brewers that make only 1 beer. And that has a pretty direct phrasing in SQL. So select the beer name from beers where the manufacturer belongs to the set of these brewers. Okay, get the name of a beer from the beers table where the manufacturer of that beer is one of the manufacturers who only makes 1 beer. So hopefully this will give me the same result as we had before. It should include 80 shillings, it should include Cascade Lager, it should include Chestnut Lager, and so on. So let's have a look. And yeah, it looks kind of close, right? Hopefully that'll be the same as the query that we had before. Let's back up to that one. That's the one, isn't it? So you can see we're getting the same set in both cases. So 2 different ways of solving the same information request. Which one's better? In general, this is better. Nested queries like we had in the previous example, which is that one there. So we've got a query that relies on the results of another query, are generally less efficient than queries where there are no nested subqueries and there are just joins. So try to avoid these. On the other hand, often these are easier to understand than ones like this. In this case, they're probably both easy enough to understand. But often if you're developing a query by incrementally, you end up having, I've got a partial result, so I can use that partial result in a context like this. So in general, try to avoid nested subqueries where you can. Alright, find what? The beers are the only one by the brewer. Find beers that are sold at bars where John drinks. Okay. So we've got drinkers who frequent bars, and what were we interested in? Beers that are sold at those bars. Alright, so we need to look at frequents, so find out which bars John drinks at, so that'd be a good place to start. And once again, why not create a view for that? Give a short name for frequents, and I didn't need to use that anyway because if I spelled the field name correctly, what's the frequents? Table effect. I didn't need to drinker name or drinker and bar. Oh, okay. Was it easier than I thought? Yes. Frequents where drinker equals John. Right, so that gives me a view, so I can start from. Gives me a list of all the bars where John is a drinker. Alright, what was the query was, find beers sold at the bars where John drinks. Well, once again, we could use this query and we could select beers that are sold in the sold relation, and the bar that they're sold in is a member of this set. So I could use that nested subquery approach. So select beer. Oops, sold. I should have put s.beer, and hopefully I got the attribute names correct. Let's just check. Where's the sold? Oh, it's just called, it's not called sold in anyway, it's called sells. Bar or beer anyway. They're the field names. Where the bar is in. Of course that's going to fail because there's no such table. And in this context, I don't actually need to use the shorthand name S. I can just put beer sells and bar. Alright, so they're the beers that are sold in the bars that come from the set of bars where John drinks. We got duplicates, but we can easily get rid of them using distinct. Generally, what we're interested in is distinct. If you get an information request and it doesn't say distinct, generally that's implied. So that's the set of beers. Alright, find beers sold at the bars where John drinks. Oh, how many beers does each brewer make? I decided to rearrange the questions a little bit. We've already done that one. Which brewer makes the most beers? This one is interesting. We've already got a view that can count the number of beers that a brewer makes. That's NB. Which brewer makes the most? Let's have a look. So now, I know some people will do this. Yuck. It may be incorrect. Give me a context or give me a situation where that would be incorrect. Or maybe better, only partially correct.
2 brewers having the same amount.
Correct. So if there were 2 brewers that made 5 beers, because I've done a limit of 1, only the first one would appear. So those kind of solutions are yuck. Don't use them in general. Unless you've got an absolute cast iron guarantee that there's not going to be duplicates in the thing that you're ordering by. Right, so given that we can't do it that way, what can we do? And what was the actual question? Which brewer makes the most beers? Alright. And now I may as well actually use the proper name from once again, and in this case, I don't think we can avoid a nested subquery. So we want the brewer comes from that NB table where the number of beers that they make is equal to the maximum number of beers made by any brewer. So a couple of interesting things about this. I'll just run it first. Okay, so Carlton. And if there were 2 manufacturers that made 5 beers, they would both appear as a result of this query. A couple of interesting things here. We know for sure that this query is going to give us a single value. Single column, single row. So a single value. If we know that, then we're allowed to use equals. In the previous examples, the subquery had been returning a set, like the set of bars that John drinks in and things like that. In this case, we know it's a single value, so we can use an equality test to check. So that's quite a common kind of structure that queries have if you get asked the question like, which X has the most Y? So it's worth learning a few of these little patterns, if you like. Right, let's look. Bars we either Gernot or John drink. So we need the names of the bars. In fact, I think we've already, don't we already have a view? John's bars. What if we make another view like that that's Gernot's bars? Let's have a quick look at how we define that. So select bar from frequent where drinker equals John. This is where underscores might actually make things a little bit clearer. here, and we can say select staff. And we can say select staff. The actual question was where either Gernot or John drinks. Okay, so what we've got two sets, and what we want effectively is the union of those two sets. And it turns out, surprise, surprise, that Postgres has a union operator. So let's do this. So I can get a set of bars that John drinks at. And I can write a query like that. So you take the union of two sets, and that will give me that. So if you look up here, we've got Lord Nelson Royal, Goodye Bay, Lord Nelson Australia. The union is all of those. And the next question was bars where both of those people drink. We've got two sets, we want the intersection. And Postgres has an intersection operator. So there's only one bar in common between those two sets. Okay, so the relational model is all about sets and tuples, so there are set operators. If you wanted to answer the question, what are the bars where John drinks but not where Gernot also drinks? There's effectively a set difference operator, which I think the syntax is except. So that gives me the two bars that I drink that Gernot doesn't. Yeah. And you can do the converse, you can say which bars does Gernot drink that John doesn't also drink in. Alright. Question 13. Find the bars that serve new at the same price as the Goodye Bay Hotel charges for VB. Reasonably straightforward. The query sounds complicated, or the question sounds complicated, but you can break it down pretty easily. First thing you've got to find is the price that the Goodye Bay Hotel charges for VB. And you can do that as a view if you wanted to. Not that it's a particularly useful view, but once you've got that, that gives you a single value, and we can use the kind of trick that we use with finding the manufacturer that made the most number of beers or whatever that query was. So we'd be looking for bars that sold another beer new at the same price as Goodye Bay Hotel charges for VP. Okay, so let's have a look. That's what I wanted. So select. And now what was it? Find bars, so we're interested in just the bars. So the beer is new, and the price of that beer is equal to the price where the beer is VB, and the bar where it's sold is Bay Hotel. So that subquery is the one that gives us the price for VB Coogee Bay Hotel, and then what we're interested in is finding a beer called New, sold at some bar for that same price. Okay. So let's see if I got it right. Nobody sells. That's possible. Maybe I got it wrong. Well, let's have a look at the sales table. And let's order by price. Alright, so what we're interested in, I know why, because it's not called VB, it's called Victoria Bidder. Alright, but in any case, this is useful to look at. So we've got Coogee Bay Hotels sells Victoria Bidder for $2.30. The Royal Hotel, now we want to find any bars that sell New for the same price. So we can see that the Royal does, and it's the only one. So if we get the query right, we ought to get the Royal Hotel as the only answer. And that's starting to get a bit, let's just reformat that. Might make it clearer, or it might not. So that subquery here gives us a single price, the one that we were asked for, and then we can go and use that price in the query and we get the Royal Hotel. Okay? And we know that's the correct answer because we checked. Alright, what else? Find the average price of common beers. Alright, first thing, we need to find what beers are common beers. And getting a set of common beers would be useful, and working out what common beers are the ones that are served in more than 2 hotels. In other words, sold in more than 2 hotels. So this one is a little bit interesting because it introduces a new construct. So select, let's just select everything from the sales table. We can't do select. No, we don't even need where. What we want is so we want for a beer. Doesn't help to make spelling mistakes like that, does it? From cells, group by beer. Okay, so run through the cells table, group all the beers together. For each beer, count the number of bars that it's associated with. And alright, so we can see Beauregard box served at 1 bar, 3 sheets, 1 bar, VB served at 4 bars, and so on. Now I've forgotten what the question was. Find the average price of common beers. Okay, so my suggestion at this point would be to make a view. And then we can get a list of common beers at any time. Oh no, they're not. Oh, They're not common beers. Some of them are uncommon. I forgot to do the second phase of the query, which was kind of the whole point. Group by beer. But what we're interested in, we're only interested in groups where the count, i.e. the number of bars, is greater than 2. I think it was strictly greater than, was it? More than 2 hotels. Okay, how to do that? Well, there's another construct called having, and that allows you to make tests on group properties. So in this case, we're interested in a group where the count of the number of bars is greater than 2. This allows me to introduce another construct, create or replace. Alright, so now I've got a different view. Alright, so these are the common beers, and if I was interested, I could probably get rid of the count. But in any case, I can say select beer from common beers if I want to do that. Alright, so the question was, what's the average price of common beers? Okay, so to get an average price, we need to group the common beers and then take an average of the price that they're sold for. So we've got common beers. Let's go in here. The beer and the average price. From beers that are sold and it has to be a common beer, and then we want to group by the beer. So I go to the sales table, filter out just the beers that are common, and then form the groups of those beers, and then compute the average price. And well, subquery has too many columns. Good point. So our subquery has beer count. So all we got to do to fix that is make sure that we just get the beer component from that in that order. Give us that. There are ways of formatting these floating point numbers so you don't get all those decimal points. Alright, I reckon that'll do for today. So hopefully you've learned a little bit about developing SQL queries given an information requirement. Alright, next week.